plants are attacked.
Okay, question 12. Potato plants are attacked by leaf-eating caterpillars. I am not even attempting yet again to pronounce that bacterium, which can be used to control these pests. The bacteria produce a protein, which is BT toxin, which kills these caterpillars. Explain how an attack by leaf-eating caterpillars causes a reduction in crop yield. Okay, so what we're looking for, if we've got leaf-eating caterpillars, okay, that will decrease leaf area, which means less photosynthesis. And if there's less photosynthesis, can't even spell photosynthesis, that means that there's less energy for growth because they've got less glucose made. Okay, so your first point is here. Decreases leaf area, less photosynthesis, and then link it to what's happening for growth. I didn't actually think there was anything else I would have gone by, but when I checked the mark scheme, they also said that you could have had disease being carried if the caterpillars were a vector as well. And if you have disease being carried, then that decreases health and that decreases growth as well. Okay. State an advantage of using this type of biological control rather than using chemicals. Well, that's just basically anything that's a good thing about not using chemicals. So basically you don't have any other impact to, and this could be the environment, to environment of the chemicals. It also could mean that you've got no other impact to, we're going that one, to other organisms which might be harmed by it. There is also the issue of biomagnification. If you don't have any chemicals, this can't happen. Magnification. Okay, that's when you have kind of a small number of particles of a particular chemical at the bottom level, but then in a producer, when you go up to the producer, they might have quite a few more of them, and then when you go up to the primary consumer, they get everything that was in each of the producers which they ate, so it gets more and more densely packed, and eventually get to the point where it just kills. So, yeah. In the mark scheme as well, they also gave bioaccumulation as well as biomagnification. They also said that you wouldn't have the issue with resistance being built up to the chemical. Basically any reasonable advantage. There's so many in that one. Okay, B. BT toxin does not kill all caterpillars. A study was carried out to investigate the effectiveness compared with the modified BT toxin by exposing different groups of caterpillars to them. Results are shown, so we've got the number tested, number surviving, percentage killed, BT toxin alone, the modified alone, both being used together. Okay, complete the table to show the percentage of caterpillars killed by the BT toxin alone. So we're looking for this number here. So what we've got is the number tested and the number surviving. So the percentage killed would be the ones that didn't survive. So you need to do 240 minus 204 to get our ones that actually survived it. And then to get our percentage, we take that over our original, so over 240, which gives us 15%. Okay? The BT toxin and modified BT toxin work by different mechanisms. Use information from the table to justify this statement. Okay, if they work by exactly the same mechanism, then they should kill the same number of caterpillars. Okay, but what we've got is something very different. You have 65% killed by the modified BT toxin and 15% killed by the BT toxin, and that added together gives us our 80. So yeah, you could just state that basically. You get 65% killed by the modified, 15% in the original. Together they make up the 80% that you get with both of them together. And that's what you're looking for. And that's the answer, and that's the question.